Assalamualaikum everyone. Welcome back to the channel. And today we are moving into lab 4, Introduction and Implementation of C Programming on ATMEGA 328P and interfacing hex keypad with ATMEGA 328P using Atmel Studio and Proteus. So, uh, objective of this lab is the main objective of the lab is to familiarize with the basic interfacing of hex keypad to learn practical implementation of C coding on ATMEGA 328P and or ATMEGA 2.60. Introduction hex keypad. Hex keypad is a peripheral that connects the DE2 through JP1 and JP2. We have 40-pin ribbon cable and it has 16 buttons in a 4x4 grid labeled with the hexadecimal digit 0 to F. An example of this can be seen in the figure 1 below. This is the example of hex keypad. We have C, D, E, F, 0, 1, 2, 3. This is 4, 5, 6, 7, and 8, 9, A, B. We can use so hex keypad pins are R0, R1, R2, R3, C0, C1, C2, C3, and J pins are 0 to 7, and JP2 pins are 0 to 7 also. These are row 0 to the row 3 and column 0 to column 3. There are 4 rows and 4 columns. This is the theory of some hex keypad. Hex keypad interface is simply arrangement of 16 push buttons which is 4x4 matrix. It is shown as there. These are the 4 registers in this which we will prove when we press the button. Here you can see in this press on the button. The register will be on and the connection will be on to C1 and or R1. So this connection will be created here. For hex keypad, this is connected to 2 pins and row 1 to row 4 and C1 to C4. BCD 7-second display or digital decoder IC is a device which converts one digital format into another, and one of the most commonly used devices to doing this called binary coded decimal BCD 7-segment display. 7-segment display LED, light emitter, or LCD type display provide a convenient way of displaying information or digital data in the form of numbers, letters, or even alphanumeric characters. This is the common cathode, common anode configuration, and this is the A, B, C, D, E, F, and G. This is the diodes connections. This is and this is the truth table for LCD display. When 0 will be on, then A, B, C, D, E, F will be on, LEDs 1 for B, C, and so forth and so on till 9. Software procedure Atmel Studio and Proteus we have elaborated in previous videos. For hardware implementation, I have explained in last video also. So activity 1 is write a program for array ATMEGA 328P or ATMEGA 2.60 to interface to 7-segment and make counter from 0 to 99. For this we have code here just to show you. And we have first we define the frequency of CPU, 16 megahertz, include library and delay library. Then we have DDRB in port B and port C output, and we have created a count name array to count the numbers. This is the array to print 0 to 9 and replace with the replication variable. While one this code for run till that this condition will be true. For this for loop will be placed to for start for 10 digits, and port C set give the value of count to port C, and for K this for loop will be started for this is for tens place, this is for unit place, and call delay, and let's this is the same code I explained earlier, and this is the Proteus simulation. This is for unit place, and this is for tens place. This is for unit place, and this is for tens place. So we have now move on to our next task. Activity to write a code to interface the hex keypad with ATMEGA 328P and glow an LED with the input from any keyboard button. So this is include library and delay library. This is the frequency of CPU. So this is DDRV in port B 0 to 8 bit, 7 bit. This is the basically the role. The bit is the array for 8 digit array, and this is port C as output, and port B the value of X. This array will store in the port B, and the while one start port B is equal to X of 0, where first value will be give to this, and if it B uh, or this, the port C will be the 0 cross 06 will store to port C. As if pin B at X5, this will be then port C will store port C here. And then this is the similar code ahead. Let's start the simulation. This is okay. And this is the code I explained. And this is the Proteus simulation. When you press some numbers, the number will display in this 7 segment. And this is just Proteus simulation registers are connected with the otherwise the stray voltage will be going through this. For this is the hardware implementation of activity 1, the digits, and this is the hardware implementation of site activity 2. So in this lab, we have learned about the interfacing of hex keypad and the complexity in the game performing and how it can overcome. And we have learned about the practical implementation of the hex keypad and the 7 segment using Arduino ATMEGA 2560. Thank you so much for watching, and we'll cover next lab 5 in the upcoming video.